You want to compute a derivative. Is it possible to do it in your calculator? Well, under the right circumstances, the answer is yes, you can do a derivative in your calculator. For example, let's just say we have y equals x squared as a simple one, but for a calculator, it doesn't matter how complex it is. Now, we all know the derivative is 2x, right? The calculator will not tell you that. I'm sorry, it just won't. Now, I'm talking about the TI-84. If you have an 89, that's different. However, the 89 generally is not allowed on exams for that exact reason. So I'm going to talk about for the 84 that is likely allowed on your test. Well, since it won't do that, what will it do? What if I were to say at x equals 2? So we want the derivative of x squared at x equals 2. Now this question, it will do. It will give you a numeric derivative. So there are a few ways we can go about that. So the first thing I'm going to do is go to math. And then over here, number 8 is n-deriv. So when I do this, we want to do now, it's a little bit different depending on which 84 calculator you have. So in this case, what you would do is we just need to tell it the derivative with respect to what variable. So I'm just going to put x here. Of what? So let's just say x squared. That's the function I want to take the derivative of and move over here at x equals 2. That's what it's asking for. So when I hit enter, it gives me the answer is 4, which of course is 2 times 2, which is 4. That is correct. Now, if you have a slightly different calculator, different versions of 83 and 84, they're pretty much the same thing. Except when you go into the n-deriv, you're not going to see this kind of a menu almost thing. Instead, you'll see n-deriv on your calculator, and then it's going to ask for several things. You have to know the order. So this calculator I'm showing on screen is a bit more intuitive than something like 83 calculators. So what you would do here is you just tell it the function with respect to x at the point 2. You just have to memorize the order. But otherwise, it's the same thing. It'll do all exactly the same. So depending on which calculator, that's how you would go about it. Now, either way, you could, if you wanted to, up here, instead of going to the x squared here, instead of typing it in here, maybe you have a really complex function you don't want to type in here. Instead, you can put in a vars, yvars function y1. So I'm going to tell it y1, where y1 is whatever I put in here. I'll just go ahead and put x squared here just to demonstrate, but you can do whatever you want there. So now when I hit enter, it gives me 4 again, because it's just using that same function. So you can do it either way. However, there is a third way that I think is, well, frankly, even easier in most cases, but not all. So that's going to be just go directly to the graph. Y equals, plug it in here. Go to the graph, make sure you can see the graph at x equals 2. And then you can calculate under second calc. One of the options is an integral. See number 6 is the derivative is what we're doing here. So I'm going to hit number 6. And then it asks you where you're going to look at. In my case, I'm still looking at 2 just to give you the same answer before. So I'm going to look at 2 and hit enter. And now it gives me the derivative is 4. So that is several different ways that I can compute the derivative of a function using just my calculator. Now, we know how to do derivatives. What about integrals? Well, it turns out an integral is pretty much the same. For an integral, let's go ahead and quit out. And we'll talk about this first method is to just go to the math button and then again calculate. There is a numerical integral, fn int. So I'm going to type that and it gives me something very similar. So notice again, it will not actually compute an integral. Like if I give you y equals x squared, we know the integral, let's just write it as the integral of x squared dx. We know that's x cubed over 3. And again, this will not do that. The calculator will not give you that answer unless you have a more advanced calculator like the 89. But knowing that, we can get information because if I were to say, instead of the integral being x cubed over 3, what if I want the integral of x squared from, say, 0 to 1? That the calculator will do. And as you might guess, I'm just going to type the integral from 0 to 1 of, we'll type in my function here, x squared, and we tell it with respect to x. So that tells me the answer is 1/3. Now, just like before, if you want to plug in the y1 instead of x squared, that works just fine. And also, if you wanted to go to the graph and calculate the integral, that's number 7, you'll just go lower limit is 0, enter. Upper limit is 1, enter. And it gives you the answer is still 1/3. The reason I really like this is if you take a look, it shades it. It's not really shown here. Let me go ahead and zoom in a little bit just so we can see this just a little bit better. And it doesn't highlight it anymore, so let me go ahead and calculate that integral again from 0 to 1 as before, and it highlights it. I really like that because it shows what the actual value is, because remember, an integral is just the area under a curve. So now we know how to take derivatives and integrals of functions on our calculator.